Okay, so last week we were discussing about the cash flow diagrams. I hope you can hear me. Just confirm whether you can hear me and you can see my screen. Someone please confirm whether you can hear me as well as you can see my screen. Yes. Can you hear me properly? Can you see my screen? Yes, okay. Okay, so last week we were discussing about the cash flow diagram. So if you remember, the cash flow diagram is something looks like this. So we basically use an x-axis to represent the time frame. It can be either in years, either in months, or either in quarters, or whatever a timely manner. And the y-axis is representing the cash inflow and the cash outflow. If it is cash outflow, we basically draw the arrow downwards. If it is a cash inflow, then we draw the arrow upwards. So there are basic rules that we need to follow when developing the cash flow diagrams. We discussed those things that day as well. So anyway, any cash inflow or cash outflow, regardless of whether it happens in the mid of the year or at the any day in between 2 years, we basically consider the cash inflow or cash outflow happened at the end of the year. So that's why we have this 35,000 at the end of third year. It may be happened in between the year 2 and year 3, but we consider it happened at the end of the third year, at an end of any year. So at the end of fourth year, we have a cash outflow of 15,000. Likewise, we can draw the cash flow diagram accordingly. So the rules of drawing these cash flow diagrams as per our discussion in the last week. Rule A is the cash flows cannot be added as well as the cash flows cannot be subtracted unless they occur at the same point in time. So that is why we basically need to identify the present value of any future cash inflow or cash outflow, or else we need to calculate the future value of present cash inflow or outflow. So we discussed several methods to calculate the future value once the present value is given, as well as to calculate the present value if the future value is given. Rule number B, or rule B, is to move a cash flow forward in time by one time unit. It can be either year, either month, or either quarter. Multiply the magnitude of the cash flow by 1 plus I, where the I representing the interest rate. So this interest rate is simply reflecting the time value of money. What we call as the time value of money, we learned that any amount of money, let's say for an example, $1,000 worth today will not be equal to $1,000 tomorrow, because the time value of money changes. So to calculate the particular cash flow, or to move a cash flow forward in time by one time unit, we need to multiply the magnitude of the cash flow by 1 plus I, where I is representing the interest rate. Rule C is to move a cash flow backward in time. Let's say that there's a future cash inflow or cash outflow happen. We need to move it to the present value. So to move the cash flow backward in time by one time unit, we should divide the magnitude of the cash flow by 1 plus I. So to move forward, we should multiply it by 1 plus I. To move forward in one time unit, we should multiply it by 1 plus I. To move backward by one time unit, we need to divide it by 1 plus I. So these three are the main rules of cash flow diagrams. Are we clear? This is very important in terms of relating these cash flow diagrams into its present values as well as into its future equivalent values. Any questions? So these two slides are just a recap of what we did in the last lecture, because today we are focusing more into the example questions. So where you need to get some hands-on experience on how to calculate these cash flows and how to draw a cash flow diagram. I hope this is clear for you. Last rule. Okay, rule C. So rule C and rule B are the same rule, but just the opposite. Rule B says to move the cash flow. It's something like this. Let's say this is our cash flow diagram. So we basically, I'm referring to the rule C. We basically receive 35,000 at the end of third year. So this 35,000 worth in third year after 3 years will not be 35,000 today. So in order to get the value, the actual present value of 35,000 today, we need to move it towards the left side or backward, right? We should move this 35,000 backwards. So to move this 35,000 backward by 1 time unit, that means to take it to the second year end, we should divide this 35,000 by 1 plus whatever the interest rate given. On the other hand, if we need to move this 100,000 into this third year, the present value into the future value. So to calculate the 100,000 after 3 years, what is the value of this 100,000? We need to forward this cash outflow of 100,000 by 3 years. So to move this 100,000 by 1 year forward, we should multiply this 100,000 by 1 plus interest rate. Is it clear now? Yes, okay, thank you. Okay, so these are the 3 main rules that we should follow in order to deal with these cash flow diagrams. So relating a uniform series, what we call as annuity, to its present and future equivalent values. What happens in this uniform series is at the end of each year or each time period, we will get a uniform amount of value. It can be either cash inflow or cash outflow, but a uniform amount. So let's say for an example, if it is 5,000 after 1 year, another 5,000 after second year, another 5,000 after third year, likewise the uniform amount. So to relate this uniform series or the annuity to its present and future equivalent values, we can use this method. So the present equivalent is what we denoted by capital P. So whatever the value we have at the start, and the future equivalent at the end of the period. So the period or the time period, it can be increased by 1 year, 2 year, 3 year, likewise up to n number of years or n number of interest periods. If we denote the uniform amount we receive or cash inflow or cash outflow as capital A, and the interest rate by simple I. So P is the, or capital P is the present equivalent value which occurs 1 interest period before the first uniform amount. Here, 1 interest period before the first uniform amount. So the first uniform amount received after 1 year. So 1 time period or 1 interest period before the first uniform amount, that is the 0th position. Then the capital F, the future equivalent value, which occurs at the same time as the last uniform amount received. That is, after n number of periods from the present equivalent value. Capital A is the annual equivalent value or the uniform amount we receive annually, what we call as annuity, which occurs at the end of periods 1 to the end of period n in each of time periods, in the end of each time periods. So including the end of period 1, including the end of period now n, from first period to the nth period, at the end of each time period, we will receive this annual equivalent value. So this is just how this particular equation has been made up of. For each cash flows, let's say from first year to the from the end of first year to the end of nth year. So if you remember in the school days, you might have learned about calculating the series. So taking the sum of series. So similar to that, if you remember last week, we learned about these notations. F over P, future equivalent value, and the P is present value. Likewise, we have several equations for this, which we can represent by the formula form like this. So at the end of first year, at the end of second year, at the end of third year, likewise, up to the n number of years, we can easily calculate the cash flows. So if you take the sum of all these cash flows, you will end up with this equation. F is equal to the annuity multiplied by 1 plus I to the power of n minus 1 divided by the interest rate. So in this equation, the quantity of 1 plus I to the power of n minus 1 divided by I, whatever the quantity within this bracket, is what we called as the uniform series compound amount factor. We discussed on this thing last week as well. Uniform series compound amount factor. So these are based on the mathematical series. So how to calculate this thing? So I have just included this slide just to get an idea how this general equation has been developed or derived. So simply, to calculate the uniform series to future equivalent values, the future equivalent value should equals to A into the uniform series compound amount factor, that is the 1 plus I into the power of n minus 1 divided by simple I. So this is an important equation that you might use in calculations of these uniform series or annuity related future equivalent values. Let's say you need to find the present value when the annuity is given. So from this equation, we know the future value is equal to annuity or the what we called as the uniform value that uniform amount of value that we receive at the end of each year multiplied by the 1 plus I to the power of n minus 1 divided by I. To calculate the P when the A is given, so we should substitute this F in the previous example by this one, because we know F is equal to P into 1 plus I to the power of n. If you remember last week, we learned about this equation to calculate the future value once the present value and the interest with the number of years given. So we can simply substitute this f by this equation and make the p or the present value as the subject. So if the a value and the I, the interest rate and the number of periods are given, we can easily calculate the capital P value, that is the present value. So the present value equals to a into 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. Any questions regarding these two equations before moving forward? Anything that you need to clarify or anything that you didn't understand? Because from this point onwards, you will have several examples to do in your own. So I'll give you some time to do those works alone, and then you can put your answers in the chat, and then we can discuss your answers as well. Any questions? No questions? Okay, if we don't have any questions, we can move forward for an example. This is a simple example. If you remember, we did some similar kind of examples last week, but with different patterns. So you may be able to use the same methodology here as well. So first of all, I'll let you some time to do this example and put your answers in the chat. Then I'll give some hint to how to get the answer for this one as well. What it says is a recent government study reported that a college degree is worth an extra $23,000 per year in income compared to what high school graduate makes. If the interest rate I is 6% per year and you work for 40 years, what is the future compound amount of this extra income? Can you give it a try and put your answers in the chat? It doesn't matter whether your answers are correct or wrong. Just try to do it and put your answers in the chat. Okay, we got one answer from one student. What about others? Okay, another different answer from another student. If I give you a hint, if you remember, we should use the same viewpoint that we used to solve this problem, which we actually used for a lending of money in the last week as well. So if we lend 23,000 of extra annual income to a saving account or some other investment of vehicle, the future equivalent value is the amount that can be withdrawn after 40th deposit is made. So something related to that. So is it the same way that you have think of this question? I mean, the two students who have answered, you can put yes or no in the chat. Okay, answer for this question, yes. Let others try for a bit as well. Okay, if you remember the equation that we just learned in the previous slide, it says the future value or the future compound value f is equals to, I hope you can see what I'm annotating here, f is equal to whatever the annuity, the amount that we received annually multiplied by 1 plus I to the power of n minus 1 divided by I. So if I replace the values to this equation, the annuity is given as 23,000 per year. 23,000 multiplied by 1 plus I. When you put this I, it should not be 6. It should be, since it is 6%, that means 1 plus 0.06. 6% is 6 over 100 to the power of n. The number of years is given as 40 years minus 1 divided by the I value again 0.06. So if you solve this, you should probably get the answer somewhere around I think as one of the students has correctly get the answer, 3.5 million, somewhere around 3.6 million actually. 3,559,530. So 3,559,530. This is the future compound amount of this extra income. Clear now? Is it clear now? There can be questions where the A value or the annuity, the interest rate and the number of years are given, and you will be asked to identify the present value, not the future value. So in that case, in instead of using this future value, you need to replace this future value by the equation that we learned last week. That is, future value is equal to present value to the power of. So future value is equal to, if you remember this equation, future value is equal to present value multiplied by 1 plus I to the power of n. Therefore, if in this case, if they were asking to identify the present value, if not in here, they have asked to identify the future compound value. But let's say in the similar kind of question where they ask for the present value. So if they're asking for the present value, you should subject this present value, like instead of this future value f, you can replace this part to the equation and then subject the p-value. Did you get that? So there are some things that might be helpful for your exams as well, because you might get some questions where you might not ask for calculate the future compound value. Instead, they will ask you to identify the present value. Okay, I'm clearing the drawings here. Moving forward for another example. So this is another type of example of questions that you can ask in terms of these cash flow diagrams. Here what they say is, there are two alternatives for a construction firm to purchase a road roller which will be used for the construction of a highway section. So the cash flow details of the alternatives, these two alternatives are given as follows. The first alternative, the initial purchase cost is 1.5 million. So basically they are giving us the cash inflows and cash outflows. So we should identify what are the cash outflows and what are the cash inflows. Annual operating cost is 35,000 starting from the end of year 2, because it is negligible in first year. So at the end of first year, you don't have any annual operating cost. But starting from the end of second year onwards, you will have an annual operating cost of 35,000 till the end of the useful life. Annual revenue to be generated is 340,000 for first 4 years, and then it will be 320,000 till the end of the useful life. At the end, expected salvage value is 430,000 and the useful lifespan is 8 years. This is the alternative 1. For the second alternative, initial purchase cost is 1.8 million. Annual operating cost is 25,000. Annual revenue to be generated is 365,000. And expected salvage value is 550,000. So the lifespan is 8 years again. Find out most economical alternative on the basis of equivalent future worth at the interest rate of 9.5% per year. So the I value is given for both alternatives. The N value is 8 years. So can you try to identify what is the most economical alternative by using those equations that we learned in today's lesson? You can do it and put your answers in the chat, and then later we will discuss the answers as well. Any answers? I think you need to work out for alternative 1 and alternative 2 separately, and then only you can compare it. Yes, one student has put her answer actually. And can you please put the values that you got for both alternatives along with your answer? That means the future worth value for the both alternative 1 and alternative 2 would the future worth values, and then put the answer because of this thing. Like your alternative, you might select alternative 1 or 2 based on the value. So if you put the values as well, we can check whether you have done it correctly. Okay, one student has done the question and put the answers. What about others? Even though you have got the answer correctly, I mean the alternative correctly, I think there might be some mistake in the calculations. We'll discuss the answers in the future, in the next few slides. So let's wait till others put their answers as well. So carefully go through the given information and clearly identify what are the cash inflows and what are the cash outflows. So maybe if you draw a cash flow diagram, it might be very easy for you to move forward. And when you are answering these type of questions in the exam paper, always remember you need to draw the cash flow diagram as well. Just doing the calculation and getting the answer might not give you the full marks. Okay, it seems others have not tried yet. So I'll show you how to do this as well. So first of all, if I draw the cash flow diagram for alternative number one, so it will looks like this. So at the start of the alternative, there's a cash and outflow of 1.5 million. That is the investment. Then it says after the second year, sorry, from what it says for the alternative one, initial purchase cost is 1.5 million and the annual operating cost is 35,000 starting from the second year. So operating cost of 35,000, the cash outflow of 35,000 starting from the second year up to the 8th year. And it says annual revenue to be generated of 340,000 for first 4 years. So for the first 4 years, there are 340,000 each. And from 5th year to 8th year, there is 320,000. And the salvage value of 430,000 at the end of the time period. So this is the cash flow diagram for alternative one. So based on this cash flow diagram, if you do the future value, if you calculate the future value, so it should be, so we know we can use this particular formula or format, or else we can simply do the calculation using the formula or the equation that we learned in the previous lessons. You will get the future value of 728,849. So this is a simple calculation where you need know the present value, interest rate, and the number of years. Similarly, for the alternative number two, if you draw the cash flow diagram, what it says is the initial purchase cost is 1.8 million. That is the initial purchase cost, which is a cash outflow. Then the annual operating cost of 25,000 is again a cash outflow. And the annual revenue to be generated is 365,000. That is the cash inflow. The salvage value is given as 550,000. That is again a cash inflow at the end of the period. So you can see here, initially the cash outflow is the purchasing value 1.8 million. Then you have an annual operating cost of 25,000. So it has been mentioned here. And annual revenue, expected revenue is 365,000. So it is there. And the final salvage value is 550,000. So based on this, again, you can calculate the future value for the alternative two. So if you do that calculation, you will get an answer of 647,848 as the future worth of the alternative number two. So by comparing the future worth of alternative number one and alternative number two, you can come to a conclusion where the alternative number one has the highest future worth than the alternative number two. Remember, if you are comparing the future worth, both alternatives should be calculated to the future worth value. If you are comparing the present value, then both alternatives should be calculated to the present value. Are we clear with this example? Any questions, any problems, any clarifications? All clear? Can you explain the part of 365,000 minus this part? Okay, so that is basically Here, 1.8 million, that is the initial investment cost. So we convert it into the future worth value here. Then minus 25,000, that is the operating cost for each year. So it is an annuity value. So you are converting it to the future worth value here. Then 365,000, that is the annual revenue we gain. So it's again an annual value. So we are converting this annuity into the future worth value with an interest rate of 9.5% for 8 years. And at the end, you have a 550,000 of salvage value. So actually what we do here is we are calculating the total worth at the end of the period. So we are converting all the other values into the future worth at the particular date of the end of the period. So here, why it becomes 365,000 minus 25,000 is, it's just because this 365,000 is plus, it took for the front, and 25,000 minus, it took for the back. Anyway, both of these terms have this f over a 9.5%, 8. So it is a common factor. It has been calculated separately and added as a common factor of 11.2302. Clear? So this is the common factor of this one as well as this one. So both are same. So since both of these have this 11.2302 or this common factor, so they have taken it out, and inside the bracket, they have just put this one first and this one second, because this is plus and this is minus. So you can either put here minus sign. So if you put minus sign here, this will be here and this will be here. No difference. Clear. Okay. Any other questions? So this is basically how you should do if you were given a question like this. I hope it is understandable now. Okay, let's try to do another example. We have few more minutes, actually around 15 to 20 minutes. So we will try to do this example before winding up the session. A person is planning a new business. The initial outlay and the cash flow pattern for the new business are as listed below. So you might think, because all of these questions are related to businesses and all, even though this module is business economics, we are learning the most economical principles here. So we can relate these economical principles for almost any businesses, including the buildings, construction, road, whatever it is. That is why just these examples have been taken from the economic related books, where we can practice them and we can relate them into our field of interest as well. A person is planning a new business. The initial outlay and the cash flow pattern for the new business are listed below. The expected life of the business is 5 years. So they have given the lifespan of the business, that is the capital N value, and the cash inflows or cash outflows as well. They are asking you to identify the rate of return. How to calculate the rate of return here? So the initial investment given 100,000. In you might be wonder why this 1,00. In some textbooks they have separated like 100,000s, 200,000s like this. So this is 100,000, the cash inflow of the initial investment. Then you have an annual revenue of 30,000 for each year. So it is an annual equal revenue, or capital A value is 30,000. Lifespan is 5 years. That means N capital N value is 5 years. So you can you should be able to easily draw the cash flow diagram for this particular business. After drawing the cash flow diagram, either you can calculate the present worth function or the future worth function. Let's say if you are calculating the present worth function, what they ask is to identify the rate of return. So to calculate the rate of return, that means maybe you need to identify a particular interest rate. So to calculate that particular interest rate, you might need to do some trial and errors. So the rate of return is actually the point where you will be able to fulfill the amount that you spend on investing this particular business. So where your revenue is equal to your cash inflow is equal to your cash outflow. So to identify that value, you need to do some trial and errors. Can you give it a try? First, try to draw the cash flow diagram, and then for several interest rates, try to identify the rate of return. You can try 5% interest, 10% interest, try 15%, like by some common increment of interest rate. So you will be able to identify a particular point where your rate of return is your return is changing from positive to negative. So that point where it changes from positive to negative, at a particular point where it becomes zero is the break-even point. No answers yet? Okay, you can try this out as a homework as well. So we'll discuss the answers for this question in the next class, and we'll move forward to the final lesson of the unit from the next class onwards. Thank you for your cooperation, guys. Have a nice day, and you can leave now and I think you have another lecture today, so you can get ready for that thing. Thank you. Have a nice day.